All right, any questions with that one? Now, the nice thing is, once we get those three side lengths, we can figure out sine, cosine, and tangent of either one of these two angles in here. Sine of 30, sine we know as opposite over hypotenuse. So we would go opposite, which is 1 over 2 for our hypotenuse. So sine of 30 equals 1/2. Cosine of 30 would be adjacent over hypotenuse. So the adjacent side to 30 would be square root of 3 over the hypotenuse of 2. And then tangent of 30, tangent is opposite over adjacent. So opposite 30 is the 1, adjacent is square root of 3. We have to fix that by multiplying top and bottom by square root of 3, which ends up being square root of 3 over 3. Okay? Now, you do not have to memorize these three answers at all. All right? Just draw out the triangle, use SOHCAHTOA to be able to figure it out. But then what you'll see, especially these two answers pop up quite often in lots of triangles that we do this year. So don't be afraid if you keep getting 1/2 for an answer. There's a good possibility that that's right. Okay, just because of how often we use this special case triangle here. All right, now we can do that for 30, or we could do it for 60 also. Sine of 60, sine would be opposite over a hypotenuse. So that would be square root of 3 over 2. Now notice this square root of 3 is the same as this square root of 3. These two would work together. It's just one of those things that happen. You don't need to memorize it. You don't even really need to know it, but these two end up working together. All right. The same way as cosine of 60 is 1 over 2. So we'd have a half there. Same thing with these two. All right. Sine of one of the angles and cosine of the other angle, they're always going to give you the same answer. Okay. So that's why when I told you in the past, when you're using SOHCAHTOA, you have to figure out where your starting point is. So say you start at 30, you can figure out all of the sine, cosine, and tangent answers here. Okay, but just understand that if you use the other one, you can still get all the same answers. It's just going to be in a different order, but we just know that sine of 30, cosine of 60, those two are always going to be the same. And it doesn't matter what your angle measurements are. Say this one is 27, and this one then would be 63. All right. Sine of 27, cosine of 63 are going to be the exact same answer. All right. And that's always the case. Now, we're not going to deal with those messed up degree measurements today. We're only dealing with 30, 60, 90 triangles. All right. But just realize that. Tangent of 60 is opposite over adjacent. So this would just be square root of 3 over 1 or just a square root of 3. Okay. Now, like I said, you don't have to memorize any of these answers. What you need to absolutely know is you need to know this triangle. All right. For those of you making it through the end of the year, I would guess at least 45 more lessons have something to do with 30, 60, 90 triangles, or our next triangle, which is a 45, 45, 90 triangle. All right, so this is a very important piece of what we're going to be doing the rest of the year. All right, so for a 45, 45, 90 triangle, first of all, this is an isosceles triangle, right? These two sides are always going to be the same because these opposite corner angles are always going to be the same. All right, so since they're the same, our legs, to make it as simple as possible, we're going to put a 1 down for each one of our legs here. And then to get our hypotenuse, we are going to take the leg times the square root of 2. So that would just be a square root of 2 for an answer there. All right. So then once we have those 3 side measurements, we can find sine, cosine, and tangent here. Sine of 45, now it doesn't matter which 45-degree angle you're going to start with. I'm going to start with the bottom. Sine would be opposite over a hypotenuse. So that'd be 1 over the square root of 2. Simplify to square root of 2 over 2. You'll see this answer a ton. All right, especially when we deal with cosine of 45, that would also be 1 over the square root of 2, which would also be square root of 2 over 2. And that would make sense because sine and cosine, we're dealing with opposite and adjacent. Well, if both of those are the same, then we're going to get the same answer here. Okay, tangent of 45 would be opposite over adjacent, so 1 over 1, or just 1. Okay, same thing as I said before. You don't have to memorize these answers here. Just know that you're going to see them a lot. Okay, what you do need to get down, just like up here, you need to know how to get that triangle. All right, so these are the main things for today. We've got to know these 2 triangles because the questions that they're going to ask you in the homework are just like what you see here. First of all, it says draw the necessary reference triangle and then evaluate tangent of 30. So this here tells us what kind of triangle we're going to draw. And we're going to have out of our origin, we're going to have a 30-degree angle. All right, so it's going to be in the first quadrant somewhere. And then we draw a triangle down. Down here would be our 30-degree angle. If that's 30, that means up here it has to be 60 because that is a right angle right there. All right, now we do have to draw it in the first quadrant. All right. At some point later this year, it's not going to be tangent of 30, it's going to be tangent of 330. And we have to put it in the right quadrant to be able to get the right answer. All right, so from there, once we have our 30, 60, 90 triangle, remember opposite the 30, we're going to put a 1. Opposite your 60, we're going to put square root of 3. And our hypotenuse is going to be a 2. All right, so once we have that triangle drawn out with the correct side lengths, now we can go through and find tangent of 30 here. Tangent of 30 is opposite over adjacent, 1 over square root of 3. Or we've got to simplify that, get the square root of 3 out. So multiply top and bottom by square root of 3. Gives us square root of 3 over 3. All right, and we just get that from the triangle that we draw there. Okay, for the next one, draw the necessary reference triangle and then evaluate 7 times sine of 45. All right, well, the same thing that we did before, we're going to deal with this 45-degree angle first and draw out our triangle. All right, still in the first quadrant. All right, this would be our 45-degree angle. We have a 90 here, which would make this a 45 also. All right, now we know that our 2 legs are going to be the same here, so those are both going to be 1s. And then this would be the square root of 2. All right, once we have the triangle drawn correctly, then we do sine of this, so sine of 45. Now remember, for every single time you now want to take your reference angle. We want to use this one. Obviously for sine and cosine and a 45, 45, 90 triangle, it's not going to matter. But we want to get into the habit of using the one coming right out of the origin. So 45 degrees, we want to do sine, so that's opposite over hypotenuse. So we've got 1 over the square root of 2. Which, when we simplify that, would be square root of 2 over 2. Now, this is what sine of 45 equals. So sine of 45 equals square root of 2 over 2. That's what we figured out with this triangle here. We need to figure out what 7 times sine of 45 is. So then we would just take our square root of 2 over 2 and multiply it by that 7. And we would end up with 7 square root of 2 over 2 for our answer there. Okay, I know in the past we talked about doing it a little bit differently, but this is normally the easier way to go. Simplifying down, just leave the 7 until the end. Okay, use your triangle here to figure it out, what the degree measurement would be. All right, one more page here for lesson 20. Draw the necessary reference triangle and evaluate 4 square root of 3 times cosine of 60. Once again, this 4 square root of 3, we're going to leave until the end. We're going to figure out what cosine of 60 is first. And it says to draw the necessary triangle. So, draw that triangle in here. Now down here is where the 60 degrees are going to go. All right, because that's what we're trying to find. All right, the 30 would be on top. This would be a 90. Opposite the 30 is a 1. Opposite the 60 is square root of 2. Square root of 3, and then the hypotenuse is 2. All right, so now we have our triangle drawn out. We can figure out what cosine of 60 is. Cosine of 60 is adjacent over hypotenuse, so that would be 1/2. Now we got to take 4 square roots of 3 times cosine of 60. So 4 square roots of 3 times, well, we know cosine of 60 is 1/2. So we would just multiply these two together. All right, so what we can do is we can simplify down the 4 and the 2 here to get a 2 square root of 3. And that would be the answer for this one. All right, can you guys think of any questions so far? All right, last one down here is draw the necessary reference triangle and evaluate evaluate 10 over the square root of 5. So that would look more like this, 10 over square root of 5 times tangent of 45. All right, so first thing we got to do, we got to figure out what tangent of 45 equals. So we draw out our triangle. All right, 45, 45, 90. All right, for tangent, or for this, for the 45s, we're going to have 1 and 1. And that means our hypotenuse is square root of 2. All right, tangent of this would be 1 over 1. So tangent of 45 equals 1. So then we can plug this in here for this tangent of 45. So we get 10 over square root of 5 times 1, which just means we just have to simplify this 10 over the square root of 5, which you guys know how we do that is we multiply top and bottom by square root of 5 over square root of 5, which would give us, sorry, I'm going in kind of a weird order here. I ran out of room. 10 over the square root of 5 over 5, and then these would simplify down, and our answer would just be 2 square roots of 5. All right, any questions on these? Now, this seems like a good time to tell you that, yes, your calculator can do all this for you. I understand that. But I also need to test you to make sure that I know that you know how to find this. So at some point, and this will not be Tuesday, but at some point, what we will do is your test will be broken up into 2 parts. those two parts will be 10 questions for each most of the time. Not always, but most of the time it's 10 questions on each. 10 of them with a calculator, and then 10 of them will not be with a calculator. All right, and the whole reason is you've got to be able to show that you know how to do this stuff. All right, now what we have found from a lot of the area schools, and Valley City is along with this, is that a lot of the area schools, if you go take a class in person, especially pre-calc and above, they will make you take your tests without a calculator. All right, so you need to start moving yourself away from the calculator. For some of you, at the end of this semester, you're going to be completely done with math for what you want to go into. That's fine. All right, you're still going to have to prove to me that you know how to do this. For some of the rest of you who are taking pre-calc next semester, you might be done with math after that. That's fine. You still have to prove to me. For some of the rest of you, you're going to, for maybe probably about half of you, you might have to take a calc class. All right, for you juniors, hopefully we knock that out next year then. All right, if not, then you just take it in college, no big deal. All right, but just be aware that that is coming. It will not be for your test on Tuesday. All right, so you do have to do this stuff without a calculator. So draw out your reference triangle. Then just do the algebra from there. You guys know how to do the algebra part, okay? And we've done the SOHCAHTOA stuff in the past. We're just putting it all together now. That's really all we're doing. All right, any questions for me on lesson 20? All right, lesson 21. We are evaluating functions, and we're also going to find the domain and range of certain functions. All right, so on this first page, we have 3 problems. If f of x equals x squared plus x minus 10, we need to find f of 5. All right, so to be able to do this one, we are trying to find f of 5. All that means is wherever we see an x, we're plugging in this 5. So here's an x. We're solving for f of 5, so we're not going to move this 5 at all. We're just going to set this f of 5 equal to the right side of the equation. So 5 squared plus 5 minus 10. All right, so from here, we've got 25 plus 5 is 30, minus 10 is 20. So f of 5 equals 20. All right, we do not move this 5 at all. Just leave it right there. All right, because remember what we're trying to find is f of 5. For the next one, if h of theta equals sine of theta, find 4 square root of 3 h of 30. All right, well, what this one is saying here is we're going to find 4 square root of 3, and then we've got to use this h function. Well, the h function is sine of theta here, and they tell us that theta is 30 degrees. All right, so really quick with what we just did, we could draw out this triangle, 30, 60. All right, you've just got to be able to read this. So this would be a 1, square root of 3, and a 2. Sine of 30 would be opposite over hypotenuse. So we'd have 4 square roots of 3 times sine of 30 equals 1/2. And then we simplify that down. We get 2 square roots of 3. So when they ask for 4 square roots of 3, each of 30 degrees, our answer would be 2 square roots of 3. Now, the other thing that I do not want to see, and I kind of said this the other day, is for problems like this, we want to have the exact value as often as we can. Now, there are some problems, especially when we were dealing with polar coordinates and rectangular coordinates, we have to use decimals for that. That's fine, okay? But for something like this, we want to keep it as exact as possible here. So leave this as 2 square roots of 3. Don't change this to 1.73 and multiply by 2. I don't want to see that. All right, for the next one, it says if f of x equals x squared plus 2x minus 1, find f of x minus 2. Now, these two problems are exactly the same, except we have a term, or we have an expression that we have to put in for x every time. So what that means is we've got to go x minus 2 goes in here for x, and then we have to square it, plus 2 times x minus 2 minus 1. So from what we have to do from here is we have to simplify things. So we got to take x minus 2 squared. So you can FOIL that out. We end up with x squared minus 4x minus 4 plus, and then we have to distribute the 2x minus 4, and then minus 1. All right, so then we would find that f of x minus 2 equals, and then we just have to combine like terms here. So we've got an x squared. We would have a negative 4x and a 2x would be a negative 2x. Negative 4 would be negative 8, minus 1 would be negative 9. So f of x minus 2 equals x squared minus 2x minus 9. All right, any questions on functions? All right, I know we did this a lot, maybe not a lot, but we did it quite often last year. All right, for the next, find, or if f of x equals the square root of 8 minus x, find the domain of f here. All right, well, for this, we need to figure out what are all of the x values that are going to work, okay? Now, we could list them. There's nobody saying that we couldn't list them, but you, if you're going to list them, you have to list all of them. So how we know if it works is if we can put a number and you get an actual answer out of it. 8 minus 0 is 8. Square root, and that would just be the square root of 8. So 0 definitely works. All right, we could put a 1 in there. 8 minus 1 is 7, and we'd get square root of 7. Now, the only time that this wouldn't work with a square root is when we have a negative number under the square root. That would turn into an imaginary number at that point. All right, so you could go and you could list every single one of these, but we actually don't want to do that because there are too many to list. All right, what we want to do instead is we want to come up with an equation that says all of the numbers. All right, now we know, because it's a square root, we know there's going to be, in this case, there's either going to be a biggest number or a smallest number that's going to work. We know that these work. And how we find that biggest or smallest number is we set whatever's under the square root equal to 0. And then you solve for x here. So most of you would subtract the 8 over, would get negative x equals negative 8, and then you divide by negative 1, so x equals 8. All right, now, what this tells us is this tells us our ending point. We just don't know if it's greater than that or if it's less than that. All right, and we have to figure that out. All right, so to figure that out, say we put in a number greater than this. If we put in a 9 in here, 8 minus 9 is -1. -1 doesn't work under the square root sign. In fact, all numbers greater than 8 will not work. So then we have to say, for our domain, we would say x is less than 8. But it can also equal 8, right? 8 minus 8 is 0. Square root of 0 is 0. So the domain for this one is x is less than or equal to 8. Whenever you have a square root, set whatever's under the square root sign equal to 0. Solve for x to find your boundary point here. And then you just have to test, is it greater than that number or less than that number? All right. In fact, I know you could show an XY chart. I'm going to be honest with you. This will normally lead you astray. All right. But it can be done. All right. So I wouldn't go this route. I would go the route that we talked about here. Technically, you could get there, but you're going to have to know what that XY chart actually means. All right, for the bottom, if g of x equals 1 over x minus 2, find the domain of g. All right, so once again, tell me all the x values that are going to work here. All right, well, this one's a little bit different because we have a fraction here. And what we can never have in a fraction is we can never divide by 0. Because that's going to give us an undefined region there. All right, so what we have to do is we have to figure out when is x going to be 0. Well, just set whatever the bottom is equal to 0 and solve for x. All right, so what this tells us is x cannot equal 2. All right, because if we put a 2 in here, we would get this 0 on the bottom, and we don't want that. But for this one, we can use any other number here. So the domain for this, we would say, is all real numbers except 2. All right, now that's one way to write it, okay? In one of my classes yesterday, they said, well, could you write this as x is less than 2 and x is greater than 2? Technically, these mean the exact same thing. All right, so that would be fine. You could also write it as, let's see. No, never mind, you can't do that. All right, so you could write it as either one of these. That's totally fine. You just have to tell me what are all of the x values. Now, if you just say domain x cannot equal 2, I'd go, all right, well, x can't equal 2, but you didn't tell me any of the rest of the values that do work. So this would be wrong without saying all real numbers except for x not equaling 2. Okay, so do not write it the way that I wrote it down here. Write it, chances are, as either one of these two. All right, any questions? All right, next one. Find the domain and range of the function y equals square root of x plus 4. And this time we have to graph it. Now, for domain and range, okay, obviously, as we did on the last page, you can figure those out without a graph. But more often than not, it is a lot easier to figure it out when you're looking at the graph. So we're actually going to graph this thing out first. All right, so this one we would use an XY chart. And we want to find either the biggest point or the smallest point, and that's where you set what's under the absolute value, or under the square root sign, equal to 0. and we get x equals -4 here. So that would be the very first point that you plug in. -4 plus 4 would be 0. Square root of 0 is 0. So that one does work. Then you just have to figure out, is it going to be greater than -4 or less than -4? If we put in, for example, a -5, -5 plus 4 would be -1. That would give us a square root of a -1. We don't want that, so we need to go bigger than that. All right, so what I taught you guys last year was we want to try and find perfect squares to be able to get a nice number to graph here. So what we want to do is we want to set for our first one, we set it equal to 0. Our next biggest perfect square would be 1. Excuse me. So we would have x plus 4 equal to 1, and then we just solve for x here. So x would equal a -3. That would be the next number that would give us a nice y value here. We plug in -3. -3 plus 4 is 1. Square root of 1 is 1. Then we plug in, we set this equal to the next biggest perfect square, which would be 4. Let's subtract the 4 over, x equals 0. We plug 0 in, 0 plus 4 is 4, square root of 4 is 2. Now, from there, you could stop if you wanted to. If you wanted to get one more point, we could set it equal to the next biggest perfect square, which would be a 9. Subtract the 4 over, x equals 5. So then we could go 5. 5 plus 4 is 9. Square root of 9 is 3. All right, so then we're just going to graph these out. -4 is 0. -3, 1. 0, 2. 5, 3. And then we just connect the dots. And this should be half of a sideways parabola. Remember, squares and square roots work together. All right, they're just inverses of each other, and inverses kind of bounce off of that y equals x line. Our parabola for this one would kind of go like that a little bit. And if you, I'm sorry, it'd be down here. If you flipped it over that line, we would end up with this one. Now we only have the positive one because there's no plus or minus up here. If it were plus or minus, then we would have the bottom part also. And you would figure it out the same way. All right. Now that we have our graph, we can go back and figure out what our domain is. All right. Domain is, what are all the x values that are going to work? Well, -4 is our smallest, and it gets bigger from there. So we can say x is greater than or equal to -4. We can also figure out our range very easily from the graph. All right, what are all, range is always, what are the y values that are going to work? The y values that are going to work, nothing down here works, nothing shows up. It's going to start at 0, and as x gets bigger, so does y. So we're going to say y is greater than or equal to 0. And that would be our domain and range for this equation here. All right, last one. Find the domain and range of the function f of x equals square root of x over x minus 2. All right, now, it's always easiest to look at the graph, but say I don't want to do that. We can actually look at the equation and figure out what's going to work here. All right, now we have a square root here. What are the numbers that are going to work for just the square root of x? Well, we can't put any negative numbers under here or else we'll have an imaginary answer. So for this one, it's got to be x is greater than or equal to 0. But we also have this denominator. And like we said earlier, we can't have our denominator to equal 0. So we need to set that bottom equal to 0 and solve for x. So yes, x is greater than or equal to 0, but if we put a 2 in there, we're going to get a 0 on the bottom. So we would say x is greater than or equal to 0, except for 2, because 2 would give us an undefined answer there. All right, so for our range can be a little bit harder to figure out without a graph, but this one's going to get really messy graphing it. So we're going to try and do this. All right, and this is where we can set up an XY chart. All right, so let's put in maybe 5 answers there and see what we get for our values here. All right, if we put a 0 in there into the original, we would have 0 over negative 2. 0 over negative 2 is 0. Okay, no big deal there. We're going to see what happens now when we plug in a 1. Square root of 1 is 1 over 1 minus 2 would be a negative 1. So this would end up being a negative 1 there. All right, 2, we said before, was going to be square root of 2 over 0. That's going to be undefined here. All right, so 2 is undefined. For 3, we kind of do the same thing here. So square root of 3 over 3 minus 2 is 1. This would be a square root of 3, which is equal to 1.73. And then if we put a 4 in, we would get the square root of 4 is 2 over 2 is 1. All right, now this isn't really telling us a whole lot. All right, now this might be where we need to look at the graph to be able to tell this. All right, so what we know for sure is that 0, 0, or our first point's at 0, 0. Our next point is at 0, negative 1. At negative 2 is undefined. All right, and almost every single time that's going to be some sort of an asymptote here. All right, well, what happens with an asymptote is our line is going to continuously get closer and closer and closer to it, but it's never going to cross it. Well, since this is already going down between 0 and 1, we can assume that this is going to continue going down kind of in a parabolic shape. So that's going to go down and down forever. The closer we get to 2, the further down it gets. All right, and you could test that out by putting in, if you put into your calculator 1.999, you're going to get a really, really small answer there. All right, now on the other side, we've got 3 and 4. At 3, we're at 1.73, which is what the square root of 3 equals. And at 4, we're at 1. All right, this is another one where it's going to kind of look like that. All right. And what's going to happen here on this side is it's going to continue to go down here. All right, in fact, it might actually cross down into this 4th quadrant. All right, so if we look at this graph, the range for this first half, it's everything less than or equal to 0. For this one, for sure, this one might be everything. We haven't tested on enough numbers to know for sure, but for sure, it's greater than 0. So what we would say for the range is we would say all real numbers. All right, and remember the range is just testing what values of y would work for this. And we could technically get every single number on the number line for our y value here. All right, these take a little bit more work. Okay, the more complicated the equation is, the more work that is needed for it. All right, but that's it for me. Do you guys have any questions, especially on this last one? Any questions there? All right, then you guys get a good practice in here. Lesson 20 and 21, any 25 questions. All right, now, overall, homework-wise, you guys are doing fine. You're getting a good variety of questions in. Most of you are pulling your 25 questions from the first lesson. That's fine, but you're going to need to at least practice some of the stuff that we just went over today from lesson 21. So it is your choice. Okay, if you turn in 25 questions and they're all from that, you did them well, you're going to get all the points. All right, but what I would recommend is at least pull the new stuff out of lesson 21 so you get a little bit of practice on that. Okay, but that's just my recommendation. You can do what you want. As long as you're getting 25 down, I'm good with it. All right, any questions for me at all? All right, I'm going to let you go. Remember, I see you guys on Monday during the wraparound period, and then we will have a test on Tuesday. All right, so I will let you guys go. You guys have a great weekend, and I will see you